Hi, good evening friends. Welcome to ACE Preparation League. Keeping in view the smart way of preparation you are following and the hectic syllabus our civil engineering is having, time is limited, syllabus is vast, and preparation time for the most important subjects is also sometimes is becoming difficult. Keeping in view, our ACE management has brought this ACE Preparation League only to keep you in the right spirits in the right time, that is last 35 days. At the outset, I wish you a happy new year. I wish every one of you get a good gate rank, excellent gate rank, bring laurels to you, to your parents, to your alma mater and to our ACE Academy. In the today's session, I am going to give you expected questions on irrigation engineering in GATE 2022. As most of you know, my dear friends, the syllabus of irrigation engineering is vast. The weightage is very less, but scoring even those little marks also sometimes turns the scene and gives fantastic change in your rank positively. That is why I request everyone to concentrate on the topics I specially mention for your GATE preparation. My name is Narayana Sharma. I am the ACE faculty, senior lecturer, for your comfort, for your benefit. Let us see, in the last 2-3 years, even you see last 5-6 years, irrigation engineering weightage maximum 2 to 3 marks. Maximum marks in any GATE examination 2 to 3 marks. Either you take set 1 or set 2, the maximum marks given will be maximum 3, very commonly 2, very rarely 1. Let us see. At the outset, I want to mention, because our time is limited, if you want to have a glance, water requirement of crops, I am just telling the chapters essentially you have to practice if you want to grab those 2-3 marks. Number 2, design of unlined canals. Design of unlined canals. Number 3, gravity dams. Number 4, diversion headworks. Out of 12 chapters available, if you practice these 4 chapters, I assure you, you can grab, because 99.9% of the times they will be covering the questions from this. As per the recent trends in other competitive examinations, some questions from other chapters also have come into prominence and likely to be given in GATE 2022. Keeping in view, we have given these expected questions, and you can send your live chart, you can send your doubts. At the earliest time possible, I will be giving the clarification. Good luck to you once again. Let us continue as a part of our ACE Preparation League, APL, the supporting hand to your best success in GATE 2022. Right. Let us see the first question. See the question, my dear friends. With moderate amount of leaching adoption, without special practice for salinity control, water that can be used for irrigation will have EC value at 25 degrees centigrade. Please see this. With a moderate amount of leaching, no special practice for salinity, without, you have to observe the keywords, my dear friends. Water that can be used for irrigation will have EC value, electrical conductance value, at 25 degrees centigrade in the units of micro mho per centimeter. Please recall the formula for electrical conductance. Cs is equal Q into C upon Q minus A into CIR. Q is the rate of supply of water to the field. We have to calculate C is the electrical conductance of that water flow. A is the area of the field irrigated. C is the consumptive irrigation requirement. So, when you supply Q water, how much water is still available after consumption? Q minus A into CIR, its conductance is Cs. Laboratory wise we are calculating C and we are mathematically calculating Cs. If Cs value is between 100 to 250 micro mho per centimeter, low salinity, 250 to 750 moderate salinity, 750 to 2250 high salinity, more than 2250, all these are in micro mho per centimeter at the calibration temperature of 25 degrees centigrade. This is known as C1 water, C2 water, C3 water, C4 water. Low salinity, moderate salinity, high salinity, very high salinity. It is permissible for the water to have the salt concentration or otherwise electrical conductance up to 750 micro mho per centimeter. So, if you see the question, my dear friends, without special practice for control moderate amount of leaching, water that can be used means moderate up to 750 is permissible. Correct answer for the problem is B. If you are asked the best irrigation water, then your answer is 100 to 250. Up to what salinity you can permit the water for irrigation, then you can go for B option. For this question, water that can be used for irrigation with a moderate amount of leaching is slightly adopted in practice, implies more amount of water is pure water is flooded with the land, flooded over the land, and then leaching is done. That is why correct option is B, my dear friends. For the first question, we have taken from quality of irrigation water. Is the first question we are following. Let us see one more question. Almost in 3-4 competitive exams, they asked this type of question, and it is very important once again in the quality of irrigation water. Let us see this question. Sample of irrigation water has the chemical analysis: sodium 115 mg per liter, calcium 80 mg per liter, magnesium 36 mg per liter, electrical conductance or conductivity 1.25 millimole per centimeter. The soil is classified as dash. You have to see the salinity value, you have to see the excess sodium, both the parameters you have to check up. If you look at the question, Sodium is given 115 mg per liter. When the units of elements or cations are given in mg per liter, we know we have to convert into milli equivalent per liter. For that we have to divide with equivalent weights. So सोडियम के लिए 115 divided by equivalent weight of sodium is 23. This is 5 milli equivalent per liter will be the sodium ion concentration in the water being supplied to the field of irrigation. Second one is calcium. कैल्शियम के लिए 80 mg per liter divided by 20. 20 is the equivalent weight of calcium. Molecular weight is 40 and valency is 2. 40 by 2 is 20. You will get 4 milli equivalent per liter. If you take magnesium 36 mg per liter divided by 12, you will get 3 milli equivalent per liter. If you calculate SAR value, sodium ion concentration by square root of calcium ion concentration plus magnesium ion concentration by 2. If you go further, sodium is 5 divided by square root of 4 plus 3 by 2. 5 divided by square root of 7 by 2, 3.5. 3.24 is 1.8, around 2.4, something like this. Sodium ion concentration divided by square root of calcium plus magnesium by 2. So you can see definitely it is SAR value less than 10. If the SAR value is less than 10, it is S1 water. What about the electrical conductance? It is 1.25 millimole per centimeter is 1250 micromole per centimeter. Mil 1.25 millimole per centimeter, that is 1250 micromole per centimeter. Just now I told in the previous slide, my dear friends, 100 to 250, 250 to 750, 750 to 2250, more than 2250, up to 750 C2. In the present problem we got 1250 comes in C3, So this is 1250 micromole per centimeter, that comes under C3. This is C3, this is S1. So how do you designate that irrigation water? That is automatically C3S1. C3S1 is the right option. Your correct answer is this. Some other type of question may be asked. Giving this data, they may ask you, giving the data up to here, can we use this water for irrigation? Your answer is no. We cannot use this water because even though it is S1, C3 is there, up to C2 only permissible. That's why this cannot be given for irrigation purpose. This water cannot be supplied for the purpose of irrigation, my dear friends. In the present question, they asked only how do you classify. Your answer will be C3S1. So in the chapter of quality of irrigation water, these two models are important. Let us see The next expected question, now as I told you, water requirement of crops, a very important chapter that includes the soil, water and plant relationship, different names of duty, duty at different locations, importance of duty, all these things are very important for gate examination definition wise. Definitions are very important. See the question. The ratio of area for which the permit for water is granted to the cultivator for the irrigation period to the mean supply for the base period is known as dash. Permitted area divided by average supply. Area permitted for irrigation, area permitted not actually irrigated, area permitted by Q average, it is the duty defined, duty nominal, that is why this is called as nominal duty. Duty is area by discharge. How much area can be irrigated per unit discharge? How much area can be irrigated per unit discharge? That is the question. That is the definition of duty. And if the words are changing, you will be having the different change terms of duty. Suppose duty on capacity at the outlet of the canal system, that is called duty on capacity. How much maximum area that can be irrigated? Once I know the water at the outlet point, I can calculate duty on capacity. Outlet discharge, that is discharge at the plant. There is no term like outlet capacity factor, just creation of the examiner. So, for the definition given, the correct option is nominal duty is the correct option. Nominal duty is the correct option, my dear friends. This is the third question. Suppose you might have seen some papers. What is meant by gross quantity? Duty at the head of the main canal. These two terms are also important. What do you mean by gross quantity? This term is important. It is the duty at the head of the main canal. What is meant by literal quantity? That is also one important. And the net quantity. These three parameters are important for different locations. I can just simply say, kindly remember, because you can't master the subject of irrigation engineering. Only tips, important questions you remember, because it is unwise to allot more time for the preparation of irrigation in your regular gate serious preparation. Subject is not that much important, that is why I am telling you for your better rank. Gross quantity, duty at the head of the main canal. Duty at the head of the main canal. Different names of duty at the head of main canal, that is called gross quantity. Duty at the head of the branch canal. Duty at the head of the branch canal is called literal quantity. Literal quantity. Either you can give the name and ask where the duty is defined, or you can give the complete description of the definition is known as dash, just like in the previous question. Has asked what is the ratio of the area permitted to get irrigated per unit average discharge. Mean supply of water means average value. Area permitted for irrigation, for cultivation, divided by average discharge, that is called nominal duty, normal duty or nominal duty. And at the head of any distributary canal, at the head of any distributary that is called net quantity. Outlet discharge factor is the duty at the head of the field channel. Duty at the head of the field channel is called duty on capacity. Simply duty at the head of the field channel, that is called duty on capacity, means maximum value we can say. Sometimes it may be asked, which of the following duties have got highest numerical value, highest numerical value? Your answer is obviously outlet discharge factor. Outlet discharge factor. It is the duty at the entry or exit of the field channel. This is the least one, somewhat greater, still greater, greatest value is this. You can just keep in mind, this is at the head of the field channel, and this is maximum, this is minimum. If you refer to the engineering services or other competitive exams also, this type of comparison is being asked. Duty area is very important area. Duty, delta and base period. The relationship between the three most important parameters, the water requirement of crops, how much depth of water is required, that is delta. In what time we can supply that water, that is called base period. How much area can be irrigated per unit discharge, that is called duty. How they are linked? By equating the volume of water supplied by the canal, volume of water utilized by the plant, we can get it very easily. That is why do not forget the relationships between duty, delta and base period. One more important question here, very recently we observed duty at the main canal or at the source, you can say is 160 or let us 160 hectare per cubic, let us say like this. 25% conveyance charges losses, 20% application losses. What is duty in the field? You may ask a question like this. In the field means at the location of the plant. At the entry or exit of the field channel, that is different. Duty in the field, at the location of the field, how much? I have to take both the losses into account. Obviously, to solve this problem, my dear friends, duty at the plant, I can say duty in the field means nothing but at the location of the plant itself is equal to duty at the main canal divided by conveyance efficiency, application efficiency. 160 hectares divided by 25% losses means 0.75, 20% losses means 0.8, 160 divided by 0.75 into 0.8 is 0.6, 1600 divided by 6. You can see, my dear friends, 6 into 2, 12, 40, 6, 36 again. If you check up the calculations, I hope the calculation is correct. You can see the question. Duty at the head of the main canal is given. Duty in the field is dash. In the field, at the location of the plant. Obviously, more and more area can be irrigated if you supply the same water at the plant instead of at the canal. All the losses you have to take into account. obviously duty will get increased as the water moves from source to the destination. From the source, from the reservoir to the destination, to the plant, the water will increase. The water capacity, area to irrigate will be more and more at the location of the field than at the location of the main canal. Friends, this area is also one expected area in the exam, forthcoming exam, GATE 2022. Please concentrate on the three definitions: duty, delta and base period. I have given one problem also relating those, giving the relation between the three parameters, very important area, and definitions of duty at various locations, frequently asked question in different competitive examinations in civil engineering. This is the question. We know methods of irrigation is one small important subtopic in irrigation engineering. What are the methods of irrigation? Like flooding, furrow irrigation, contour farming for hilly crops, sprinkler irrigation in hot areas when there is high water scarcity, when there are steep slopes, when there are lots of ups and downs in the field, we go for sprinkler irrigation. Furrow irrigation, small canals within the field, we provide the canals open to sky, water will be supplied at the root zone level. Such a method of irrigation is called furrow irrigation. Generally even for GATE, one question may appear on methods of irrigation. It may come because it is only guessing. Most important areas we have to touch and not spending too much time. So, the question asked is, for rice crop, what is the climate best suited? For rice is generally in semi-arid areas. Very commonly growing crop is rice. Temperature should be somewhat moderate, and humidity should be somewhat moderate. Even in the not too arid zones, moderately arid zones also, little bit high temperature also. So, if you see the low temperature and high humidity, absolutely it is not possible. Only some flowers like that only we can go. Moderate temperature and low humidity, even for that also only crops like groundnut. High temperature and moderate humidity is the best one for rice. Therefore, temperature should be high and humidity should be moderate. That is the best suitable for rice crop. Low temperature and low humidity is not suitable for any crop. This is for groundnut, etc. Low temperature and high humidity, that is for some flowers, orchids, etc. There may be other, soya beans also is one good one which will be grown at low temperatures, and high temperature and moderate humidity is the best one for rice crop. You must sometimes will get the answer by elimination process. If you know some other data, with the help of the data I will try to eliminate one or two options. Then sometimes we guess, our guess also may become true if you do the guessing in a logical way. Friends, this in the method of irrigation, understand the general methods of irrigation, the three most important one: surface irrigation, subsurface irrigation, sprinkler irrigation. Subsurface irrigation is a drip or trickle. Surface irrigation, again three important parts: flooding, then furrow, then contour farming. Contour farming only for hilly crops, coffee, tea, elachi, corundum, etc. For flooding is the most important one, like rice, wheat, etc., jawar, maize. For all these crops, flooding is the most important one. So, try to understand the correct answer. This comes under first chapter, methods of irrigation, which we study under general basics of water resources engineering, types of irrigation, methods of irrigation, etc. Let us go to the next question. Out of the conditions given, which are more favorable for sprinkler irrigation? More favorable, you have to see any negative format of question is there or not, which are not favorable. Sometimes it may be framed like that. You must be cautious while reading the question. Presence of mind is important, of course. Cautious about the keywords or tricky words, then only you will get the best success. Sometimes even by, if you do the guess with a proper reasoning, proper logic, observing the units, sometimes having the general idea about the values of some parameters in our day-to-day studies, sometimes we may conclude, we may come to the conclusion of the right guessing, right answer. Our luck may give a click for us positively. Question given, out of the given conditions, which conditions are more favorable for sprinkler irrigation? Sprinkler, by means of sprinklers, will be providing in the form of sprays through the nozzles. From the source, different nozzles will be sending out the water. Water will be sprayed directly onto the leaves, from the leaves to the branches, from the branches to the stem, the water flow will take place. You know that in the water scarce areas, high temperature areas, when the what they called when the soil is having less porosity and more permeability property, soil is having lots of ups and downs. In all these situations, there is no other scope for but going for sprinkler irrigation. Please understand should remember the conditions favorable for sprinkler irrigation. Hot, arid areas where you want to go for irrigation, areas of water scarcity, conditions favorable for sprinkler irrigation we are telling, soils having the steep slopes with lots of ups and downs, with lots of ups and downs, leveling is not properly done. Fourth one, when the soil's porosity is less and permeability is high. In these general four situations, it is always advisable to go for sprinkler irrigation. Water should be available at one source, but the land where we are having cannot be getting supplied water by means of porosity, by means of groundwater storage. Only you have to supply the water by external source. Soil cannot store the water because porosity is less, permeability is high. Whatever little amount of water you supply, its storage capacity is less, drainage capacity is high. Obviously, the little amount of water supplied will be wasted in the form of drainage, horizontal movement of water through soil. That is why in any one of these four situations, combination of the four situations, there is no other option for us except for going to the choice of sprinkler irrigation. If you see the answers, soil with low porosity, shallow soils where proper land leveling cannot be done, steep slopes and easily erodible slopes. Purposefully the question is given, soils with low porosity is given, low porosity, but high permeability is not mentioned. Even though low porosity, very low permeability chances are there. That is why even though the soils are having less porosity, that cannot be the answer. Shallow soils where proper land leveling cannot be done, yes. Some rocks, some bushes, some lots of ups and downs. Steep slopes and easily erodible slopes are there. That is why second option is correct. Third option is correct. This option cannot be totally correct. Why? Because soil with low porosity, least permeability, if you say, that is suitable for irrigation, ordinary irrigation. That is why your correct option is 2 and 3 are correct. So, B is the more better answer. You may get the immediate temptation to keep 1. Kindly observe. These are favorable conditions for sprinkler irrigation. Favorable conditions for sprinkler irrigation. See the last one, see the first option. We may get the temptation to keep the option A. Option A will be correct if we added here low porosity and high permeability. Low porosity always does not mean low porosity and high permeability. No. Low porosity and negligible permeability chances are there. This is correct option is B. Temptation we may get the temptation to keep 1 also. You must be cautious. Is one more important area. Every alternate year you will find one question on this, on frequency of irrigation. Today if we supply, after how many days we have to supply the water, that is important for us, very important area. What is the time gap between one irrigation and the next irrigation? Today I have raised the water from the present moisture content up to field capacity. Within how many days? The plants, by absorbing the water regularly, the water content is brought back to OMC. That is called, see the question. After how many days will you recommend supplying irrigation water? Root zone depth is given 0.8 meters, field capacity 30%, permanent wilting point 15%, density of soil is 1.5 grams per cc, consumed to use for the crop is 5 millimeters per day. Only 60% of the available moisture can be permitted. So, if you remember the formula, frequency of irrigation will be dW by Cu. How much water depth I am supplying every time? How much water is to be consumed by the plant every day? Every time depth of supply of water by everyday consumption of water by the plant. Depth of water per time divided by depth of water per day, you will get number of days per time. Today if I supply, after how many days again, next time you have to supply, second time I have to supply, still next after how many days, third time, like that the time interval between 2 consecutive waterings is the question asked. If you remember correctly, dW x by 100 S into D into Fc minus Pwp divided by consumptive use. The formula we are using for the frequency of irrigation is this. Formula for frequency of irrigation is given by this. All the data is given to you. It is only be careful about the units, my dear friends, because you will be under tension. 14, 15 subjects you have to traverse from that corner to this corner within 3 hours, apart from mathematics and aptitude. Most important subjects like environmental engineering and geotechnical engineering and transportation and strength of materials. Most important subjects apart from mathematics and aptitude. These 6 subjects if you concentrate, you will get minimum best rank. If you concentrate on all the 14 subjects, you will get all India first. Anyway, let us see how to solve this question. Please understand the definition. Frequency of irrigation means after how many days will you recommend supplying irrigation water. Today I have supplied, after how many days again I have to supply, the time gap between 2 consecutive supplying water, supply of water. Let us substitute the values. X is 60%. Cu is given in millimeter per day. Root zone depth is given 0.8 meters. 0.8 meters must be converted into millimeter. Millimeter divided by millimeter per day you will get in days. So, this 0.8 meter I am converting into millimeters. Specific gravity, this is a D, root zone depth. Specific gravity, density of the soil by density of water. S is equal to dry density of the soil by density of water, 1.5 grams per cc by 1 gram per cc. Specific gravity of soil is nothing but density of soil in CGS system. I have done number of problems in fluid mechanics and geotech. Field capacity 30%, permanent wilting point 15%, percent means by 100, whole divided by Cu, consumptive use, per day how much water is consumed, 5 millimeters divided by 5. Please try to simplify. Be careful about the units. You must be very cautious about the conversion of the units. All the terms, see the problem in the numerator. D is given, root zone depth is given in meters. I had to convert into millimeters. Why? Because consumptive use is 5 mm. So, root zone depth also must be converted into millimeters from meters. 1 meter is 1000 millimeters, that is why I multiplied with 1000. Try to get the answer. Saurabh Kumar, you are fantastic. 21 days is the right option. Any other one? C, correct answer. C is the 21 days. Most of you kept the answer C. Very good. Please simplify. 100, 4 zeros, 1, 2, 3, 4 zeros, 5 will give 3 times, 6 into 0.8 is 4.8, 1.5 into 3 is 4.5, 4.8 into 4 around 19.2 and 2.4, you will get approximately 21 days, 21 point something like that you will be getting. Right option is C for this problem. Many people have kept the answer correctly. C is the right option, my dear friends. This area is very important area. Sometimes only 60% of the available moisture is permitted will not give. He will say, in some problems he may give last 30% of available moisture cannot be extracted. See the wording, how the question may be given, a very commonly asked question. Out of the available moisture, last 30% is not permitted, means only the first 70% is permitted. So, out of the available moisture, I can take up to 70%. So, what is our X value here? Percentage of available water that can be extracted by the plant by means of capillary action. By means of that capillary, that is important for us. See the wording, last 30% of the available moisture cannot be extracted from the soil's capillary pores, hidden forever with a strong bonding between the soil and the water. If the question is given like that, your only thing you have to do is only, my dear friends, your formula for frequency of irrigation, dW by Cu formula in general. dW means last 30% is not permitted, 0.7, 70%, I am writing 0.7 is 70 by 100. The last 30% is not permitted means first 70% is permitted. That's 70%, I am taking it as 0.7 into S into D into Fc minus Pwp divided by Cu. This is 70%, because out of the available moisture, last 30% is not permitted, upper 70% is permitted. If you refer to the previous gate questions and other competitive exams, even in ESE prelims, you will see a question on this formula. What is the time gap between this watering and the next watering? Ek bar diya, supplied on June 10th. Next time when he has to supply the water, on what date? And go for the calendar with 21 days gap. So, very, very important area, my dear friends. You can see very easily that type of questions will be asked in the examination. Either he can give only 60% of the available moisture is permitted, or otherwise last 30% is not permitted. If he says last 30% is not permitted, 70%. Last 40% is not permitted, 60%, 60 by 100, 0.6. Half of the available moisture is not permitted, 50%, 0.5. Please try to record in the mind the standard formula. F is equal permitted percentage. What is that formula I have given? X by 100, that is permitted percentage of available moisture that can be supplied to the field for the purpose of growth of the crop, into S into D into Fc minus Pwp divided by Cu. In the place of Pwp, if his OMC is given, this is not necessary. Simple formula, S into D into Fc minus OMC divided by Cu. Very, very important. My first priority question is this question. That is, after how many days you will go for irrigation with the data of the soil, with the data of the crop. Consumptive use is controlled by crop. If the crop changes, consumptive use will change. If the temperature changes, consumptive use will change. Let us go to the next question. It is also a very good question. Please understand the typicality of the question. If the irrigation efficiency at a 10 hectare field is 80%, 10 hectare field is 80%, conveyance losses in the canal system is 10%, how much is the volume of the water required at the canal outlet for supply of 10 centimeters water depth in the field? For the depth of water 10 centimeter in the field, the word in the field is important. The word in the field is important. in the field means at the plant. So you have to calculate volume of water at the plant. I have to calculate. Irrigation efficiency means application efficiency. Conveyance losses are 10%. So your formula for volume of the water in the canal, volume of water canal divided by, or you can go in the reverse way. How do you get the volume of the water required at the plant? Area multiply with Y plant I want. How much water is required at the canal outlet? So how much volume of water required at the canal outlet? V plant divided by efficiency of irrigation. Irrigation means here application and conveyance. Because more water has to supply at canal. More water you have to supply at canal. Therefore, efficiency will go to numerator. Look at the data carefully. V plant will be 10 area will be 10 hectares. 10 into 10 power 4 square meters. V plant I am calculating area into Y plant. 10 centimeter water depth in the field. In the field means at the plant. 10 centimeter is 10 by 100 meters. It is in meter square, it is in meters, you will get in meter cube. Water will be taken in the units of cubic meter divided by area of the field into depth of the water in the plant divided by eta A. 80% is the irrigation efficiency 0.8. 10% is the conveyance losses 0.9. If you supply, all this will be in cubic meters. You know all the units are given in kiloliters. Please recall 1 cubic meter is 1 kiloliter. Kiloliter is 1000 liters. Whether you say 1000 liters or kiloliter, nothing but 1 cubic meter. If you take 1 meter by 1 meter by 1 meter, it will carry 1000 liters of water. So if you simplify this, 10, 10, 100 will get cancelled. 10,000 divided by 0.72, 0.8 into 0.9, that is 0.72, you will get around 13,900 kiloliters. 13,900 kiloliters is the option given to us. This is the correct option for the problem. Suppose, friends, look at the problem. Suppose if he has given for supply of 10 cm volume of water required at the canal outlet, for the supply of 10 centimeter water depth, the entry of the field in the place of in, if we say at the entry of the field, your answer is different. For that question, what is the option, we will see. If you are asked volume of the water at the canal outlet will be area into depth of the water at the canal. Depth of the water at the field. Between canal and field we got only application efficiency, that is conveyance efficiency, that is eta C. When you are asked, when you are given that y not in the field, at the field means, at the field if it is asked 10 centimeter water at the entry of the field, 10 centimeter water in the field, at the field, both are different. At the field means here meaning is at the entry of the field, at the entry of the field. In such a case, it is 10 hectares, 10 into 10 power 4, y field is 10 centimeters, conveyance losses are 10%, 0.9, simplify 100 gets cancelled, 10 power 4 by 0.9, 11,111.11 kiloliter. So, neglecting this 0.11, you can say 11,111 kiloliters. The data must be clearly observed. In the field means at the location of the plant. At the field, at the field he has to mention clearly. Actually, giving like the, at the field giving the question, sometimes you may get the misconception that it may be in the field only. Then your answer is 13,900 kiloliters. You must be careful about the wording. Of course, this option is not there in the question. 13,900 only is there. So, in the field means the meaning is at the field as asked implies in the field only. Do not get confused with the wrong way. Sometimes the question may be set, the wording given by the examiner may be giving us some confusion. Do not get confusion, there is no need of confusion, simple. If you are asked, briefly once again I am telling, if you are asked, my dear friends, either in the field means volume of the water in the canal system is equal to volume of the water in the field divided by eta A into eta C must be taken. If at the entry of the field, entry word must be given, otherwise the question can be taken as a wrong, or you can take at the field means in the field also. That is why I have given this question only to see the possibility of getting confused, my dear friends. How the small change in the field and at the field, how it will give the confusion. I am trying to explain. V canal is equal to V field means at the entry, field entry diya to only have to take only eta C. Understand the 2 points. In the field means at the location of the plant, at the entry means at the entry of the field means formula is different. Here eta A also coming, here eta A is not coming, my dear friends. This is the question we are having regarding water requirement of crops. Yo friends, welcome back to our ACE Preparation League. Don't forget APL. APL will support you for your success. To make you the best person, the person with the greatest success, you can rely on some extent on our ACE Preparation League. Final touch of the subject. What areas to be covered? What areas can be neglected? What subjects can be studied? What subjects that can be neglected? You can get a general idea by following the ACE Preparation League. The subjects of more weightage should be allotted with more time. Subjects of less weightage should be given less weightage. Geotechnical engineering, a very important subject. Environmental engineering, minimum 10 questions, 10 to 15 marks out of 100. Compared to those most prominent subjects, irrigation of course has negligible weightage, but it is purely based on definitions and definition based numericals. So 2 marks, you can spend some time on that, just keep your memory active, remember the definition, remember the formula, apply it and get the answer. For a geotechnical problem, if you take 1 minute, for the irrigation problem it will take only half minute or 1/4 minute. For the theory question in other subjects like strength of materials on stress strain curve, if you take 1.5 minute like that, for the theory questions on irrigation it will take only 10 seconds, 90 seconds, 10 seconds. Anyway, choice is yours. Sometimes some people will have more interest towards water, they can rely on hydrology and irrigation also. Anyway, good luck. Let us continue our question. It is also based on water requirement of crops. A model, good model I feel, that is why I have given this question. See the question friends. An irrigation canal is to be designed to deliver 6.25 cubic of water to meet the peak Rabi demand of a total 5,100 hectares of cropped area. Estimated canal losses are 85%. Duty on capacity of this canal is dash. Duty on capacity means at the field. Actually at the exit of the field we can say. Canal losses are 85%. So duty at the field is equal to area divided by discharge at the field. How much area is irrigated? 5,100. How much discharge? 6.25 cubic. Canal discharge divided by efficiency. 5,100 eta C is losses are estimated canal losses are 85%. This is a little bit printing mistake, that is 15%. So this is 0.85 is the canal efficiency. Q canal is 6.25. If you simplify, you will get around 612 hectare per cubic is the option. Please see the problem once again. It is my canal system. Canal is releasing 6.25 cubic. Here what is the discharge at the field? Discharge at the field is equal discharge at the canal divided by conveyance efficiency. This is the area of the field. I want duty on capacity means duty at the exit of the field. Duty on capacity, duty at the exit of the field. Here duty chahiye, area by discharge here. How do you get discharge at the field? Q canal divided by eta C. Area 5,100 hectare by Q field, Q canal by eta C. Q canal 6.25 divided by 0.85. If you simplify, 612 hectare per cubic is the option. 612 sorry. This is also one important question, important definition. You can get the option. Coming to the design of unlined canals, it is also frequently asked. In the unlined canals only three theories are available: Kennedy's theory, Garrett's theory and Lacey's theory. Kennedy, Garrett and Lacey. All the three are important. All the three are important for us. Here, Kennedy's equation, critical velocity ratio introduced by Kennedy's equation is to take it into the effect of what everyone knows, a silt grade, coarse silt, fine silt, sandy clay, silty clay. If the silt grade changes, silt grade mean diameter changes, your CVR value also will change. That is why silt grade means average size of silt particles. Silt charge means mass of the silt transported per unit discharge. The CVR value, we know what is CVR value in the equation. V0 is equal to 0.55 m d power 0.64. This m is called critical velocity ratio, which is a function of silt grade. Please, it will not depend on the channel cross section. Unlined canal channel cross section. Unlined canal channel cross section is always trapezium. So, this is not the correct answer. Climatic conditions cannot give the change in the velocity. So, this cannot be controlled by CVR value. Roughness of the bed is given by Manning's coefficient capital N. N has no link with M, therefore, only silt grade. Of course, Kennedy has clearly mentioned, because M is 1, M value is 1 for Upper Bhari Doab canal. For the canals under Ganges, river Ganges, M values are there. For South Indian canals, some other value of M is there, because the nature of the silt will change. Silt grade also dependent on silt nature. So, that is why it is a very important question. The CVR value is a function of dash, nature of the silt and silt grade, quality of silt. Let us go to the next question. For the silt of Upper Bhari Doab alluvium, that means the canal where thousands of experiments were conducted by Kennedy, F value is given as 1. What is the average size of this alluvium? F value is 1. So, what is the formula for F? Silt friction factor. F is the silt friction factor. F is equal, please recall, 1.76 square root of average diameter of the silt in millimeters. Try to solve. D value, F value is given and D value is asked. Median size means average size. I hope you are able to calculate. D millimeters is equal to F by 1.76 whole square. F is 1 by 1.76 whole square, 10 by 18, 5 by 9, nearly 0.55, something like that. The square is 0.32. It is also an important model. Simple formula for upper Bhari Doab canal. What is the average diameter of the silt? It is under diversion headworks. The repelling groins, which are largely constructed projecting from reverse embankments, as we know, repelling groins, anti-erosion works. We want to make the water deviated from that bank. So, this is my river. If I construct like this, I can construct like this, I can construct like this. If I construct like this, water flow will go to the other bank, means anti-erosion work. Anti-erosion work. So, definitely it must be pointing. So, this type of structure will make the water to get repelled. That is why it is called repelling groin. So, this is repelling groin. Pointing, this is my upstream direction, it is my downstream direction. So, pointing upstream is the right option. Simple theory question. You may ask, the groin which is provided to shift the axis of the canal flow, to shift the axis, your answer is deflecting groin. To make the water attracted towards the closer bank, then it is called attracting groin. So, this is the repelling groin, this is a deflecting groin, and this is attracting groin. Sometimes they will give the match the following. Repelling will make the water to get repelled from this bank. Deflecting will get the water shifted. Attracting will make the water to get deflected towards the closer bank. That is why it is called water is attracted, water is repelled, water is shifted in its axis of flow. That is how we get this. Correct answer is A, my dear friends. Let us see the next question. Canal headworks in the upper rocky reaches of the rivers are uncommon. This is uncommon because why canal headworks are not provided in the rocky areas, upper rocky reaches? More drops are required. More drops are required on resulting canal system on the canal, correct. Costly head regulators are required because of the rocky area. More cross drainage works are required, therefore your correct option is D. A, B, C, all the three are correct. Why we are not going for rocky, why we are not providing any cross drainage works, any head works in the rocky regions, why we are going for alluvial region? We know the 4 stages: mountainous region, boulders region, then furrow region, that is called a trenches region, then deltaic region. The third region in which we are providing all the types of headworks, diversion headworks, and then canal headworks. All above are correct answer. An irrigation canal flowing freely above a drainage, which in turn is flowing under pressure. Here drain is there, here canal is there. Canal is flowing freely above a drainage, which in turn, this is in turn flowing under pressure, means up to here it is there, then only negative pressure compared to here. Here area is less. When area is less, velocity is more. Continuity equation. When velocity is more, pressure is less. Here pressure is atmospheric, here pressure is less than atmospheric. Siphonic condition will be created here. Siphonic condition. Canal on the top, drainage and below on the ground, drain water is undergoing siphonic action. So, it is type 1 with siphonic action. Your answer is siphon aqueduct is the right option. Siphon aqueduct is the right option for the question. You can understand here very easily. Here depth is more, here depth is more, so velocity is less, so pressure is more. Say this is 1-1 section, this is 2-2 section. Compared to 1-1 section, at 2-2 section pressure is less. At 1-1 section pressure is atmospheric, open to sky, here the pressure is less than atmospheric, siphonic action. With the canal on the top with lesser discharge, drain with heavy water is going on the ground, type 1 cross drainage work with siphonic action. Type 1 only 2 cases, aqueduct, siphon aqueducts. So, if this water is coming at a level lower than the bed level of the canal, then you will get aqueduct only. Aqueduct is, canal aqueduct is the answer. For the given question, my dear friends, siphon aqueduct is the correct option. Let us go to the next question. Main objective use of, conjunctive use of, you know what is meant by conjunctive use of water. Central government has recommended this method to be followed in the areas of water logging to control the water logging effects, to make a given land as an area of anti-water logging area. The best method proposed by central government is, in any area where the area is waterlogged because of rise in the groundwater table, groundwater should be made to go in the downward direction. For that, pumping of groundwater is important. So, central government has given, according to the conjunctive use of water, according to this use, 70% of water must be taken from canal system, 30% of water must be taken from groundwater source. If every farmer in the waterlogged area, this is maximum 70%, this is minimum 30%, must be taken from, this is collectively called as conjunctive use. Suppose if you are asked what the question, another question in the GATE 2022, which of the following is the essential condition for conjunctive use? It is the principle given by Water Resources Division, central government, that any farmer in the waterlogged area can take, even though 100% water is available in abundantly water is available in the canal system, he can take only maximum of 70% of his water requirement in the canal system. Minimum 30% of his requirement should be taken from groundwater source. If hundreds of farmers in the waterlogged area start pumping out, groundwater table will move away from root zone depth. Once the groundwater table moves away from the groundwater zone, goes outside of the root zone depth, obviously area is free from the waterlogging problem. Crop yield will be best, quality of crop will be good, quantity of crop output is also the best. Please understand that to achieve optimal utilization of water resources, as optimal utilization is correct, maximize the crop yield, fantastic. To reclaim waterlogged areas by gradually declining the groundwater table, sending the groundwater table down and down. So, A is correct, B is correct. A very important question, my dear friends. Mere khayal mein one of the most important question on waterlogging topic, this question. Let us see. In a gravity dam, frequently a ground curtain is provided, curtain to reduce the seepage effect. To reduce the seepage effect, on the downstream side we provide horizontal filter, on the upstream side we provide curtain, that is at the heel. So, near the heel to reduce uplift and seepage, C is the right option, my dear friends. Not near the toe, not in the middle of the base, not at the middle third of the base, not correct. near the heel only, because it is the ground curtain we provide, ground curtain. So, C is the right option for that. A resign channel has a full supply depth of 3 meters, bed width of 9 meters. What is the full supply discharge in the channel? So, resign channel, means Lacey channel. Resign channel means Lacey channel. It is a trapezoidal cross section. Bed width 9 meters. Depth is 3 meters. I want resign discharge. First calculate P. B plus 2.236 D. We know the formula for wetted perimeter. B plus 2.236 D. B value 9. 2.236 into 3. 9 plus 6.708. Around 15.71. If the wetted perimeter is given, how do you get the discharge? Please recall. P is equal to 4.75 root Q. Q is equal to P by 4.75 whole square. P is 15.71 by 4.75. 4.75 into 3, around 14.25. So, around 3.3, something like that. 3.3 whole square is 11. 11 cubic must be the correct answer. You can check the answer. 11 cubic must be the correct answer. Only two formulas. First formula, for any unlined canal in alluvial soil, P is equal to B plus D root 5. Second formula, the very popular PQ relation is also very commonly asked question on the Lacey's theory. Lining of irrigation canals has necessarily to be carried out. Has necessarily to be carried out in what type of soils? Definitely sandy soil has got highest permeability, we must line the canal. Coarse soils also will have the higher permeability. So, of course, these two. Clayey soil will have less permeability, need not be lined. Fine silt and clay also, they have got less permeability. For the soils of less permeability and more porosity, you need not line the canal. Canal lining is not necessary. 3 and 4 not necessary. 1 and 2 are correct because of higher permeability. That is the question. Next question is also one important question in the lining of canals. It is once again problem on the water requirement of crops. For the data given in the table and taking core depth and core period for wheat, for rice, what is the average discharge? Area is given, total depth is given, the total depth is delta. B is given, this is 3000 only, sorry, printing mistake. So, let us see what is Q for wheat. D is equal to A by Q, Q is equal to A by D. Area irrigated is 2000. Average duty is 3000. 2000 by 3000 is 0.667. This is average value of wheat crop. Second one is Q rice. Area by duty for rice. Rice demands more water, therefore its duty is always less, around 750 to 1000 hectare per cubic. area irrigated is 1500, duty 1000, 1.5 cubic. Has asked average discharge, not the average of these two waters. For Rabi crop, how much water you have to, for wheat crop, how much water you have to supply? For Kharif crop, how much water you have to supply? Whichever is the greater one, that is the average value. Here, average value means not the Q1 plus Q2 by 2. No. If you supply the water of Q1 plus Q2 by 2, will that water be sufficient for the rice? No. If you design the canal for 1.5 cubic, we release 1.5 cubic in Kharif season, we release only 0.667 in Rabi season. So, your canal is going to work both in Rabi season and Kharif season. Our purpose of supply of water will be served. That is why whenever you are asked the word average, see the twist in the word. Whenever you see the word average discharge, you have to take the simple definition A by D, whichever is greater, that will be taken as average discharge. Your answer is 1.5. You have to see 1.5 is the correct answer. If you are asked instead of average discharge, if has asked what is the average discharge in the core season, core data must be taken into account and calculate. Anyway, that much lengthy problem cannot be given. Data may be given like this only to see that all this is surplus. This data is not necessary. By chance, if you are asked that question, then you have to apply. What is the duty? Here delta is given, here time base period is given, 8.64 B by delta, 8.64 B by delta, 8.64 B by delta will give duty, area is known, duty is known, then you can calculate Q. Q of those greater value of those two Qs will give average core discharge, you can say, or average maximum discharge, you can say. But for the given word average discharge, you need not get confused, my dear friends. Once he says the word average discharge, design discharge of the canal, ultimately for what discharge you have to design your canal, you have to design your canal, that is your answer. Kindly keep a star mark for this. Somewhat tricky, you must be cautious in the wording of the problem. A canal was designed to supply the irrigation needs of 1200 hectares of land, growing rice of direct formula which you have given. Same water is used to irrigate wheat also. How much area can be irrigated? As the discharge is constant, D is equal to A by Q. Q is constant means A by D is constant, means A delta is 8.64 B by delta. So therefore, A delta by B, A rice delta rice by B rice is equal to A wheat delta wheat divided by B wheat. Everything is known, very very simple. D is equal to A by Q, Q is equal to A by D. Same canal water, if the same canal water is used to irrigate wheat, rice area 1200 hectares, delta rice 120 centimeter, base period of rice 120 days, area of the wheat I had to calculate, delta wheat 90 centimeters and base period 100 days. Simplify, 120 gets cancelled, this is 0.9, area of wheat is equal 1200 divided by 0.9, that is 1033. 1333.33 hectares is the right option. It is a very simple model. Formula is you refer to the previous one, no, sorry. If you refer to the previous one, the basic formula delta is equal to 8.64 B by D in SI system, 864 B by D in CGS system, 1.98 B by D in FPS system. These three are important formulas you have to remember. Conversion of units is very important. First one is in SI system, delta is in meters. Second one, delta is in centimeters. Third one, delta is in feet. Let us go to the next question. Garrett's diagram for the design of online is also a simple theory question. I told you Garrett's diagram is based on Kennedy's theory and Cutter's formula 3 and 4. Lacey's theory, no. Manning's formula is only for all the canals, including lined and unlined. Manning's formula is the general formula, valid for prismatic channels, non-prismatic channels, lined canals, unlined canals. It's just mean velocity of the formula based on the roughness coefficient of Manning's. That's why Garrett's diagram is Garrett was the assistant of Kennedy. Based on the Kennedy's theory with the help of the Cutter's equation, a graphical procedure for the design of unlined canals, a very, very simple question. Let us see the next question. Consider the following statements related to the under sluices in diversion headwork, on permeable foundations. What are the points you are remembering regarding under sluices? I hope it is a theory question, but IS code has given the design discharge. We will be keeping that very close to the river bed. See, let us see the answers. The crest of the under sluices portion of the weir is kept at a lower level, correct? Crest of the under sluice portion of the weir is kept at a lower level than the crest of the normal portion of the weir, because we will be keeping these very close to the river bed with a supported platform. Then on that we will be keeping sandbags overlaying the pipelines under sluices. That is why first one is correct. They cover the silt deposited on the river bed in the packets in the upstream of the canal head regulation. It is also correct. It will cover the silt. That is why they are called covering sluices. Under sluices has got another name, covering sluices. It has got the name. The discharge capacity of the under sluice is the IS code, 10 to 15% of the maximum flood, 2 times the maximum discharge of the off-taking canal, or the maximum inter discharge, whichever is highest. 1, 2, 3, all the 3 are correct, my dear friends. All the 3 are correct. Under sluices is also got another name. Once you remember this name, second option, you may get some doubt in the examination. That is why I advise whatever is the components of the hydraulic structures, names of the components with alternate possible names is important. Kabhi, once you remember that alternate name, you will pick out the correct option. Simple theory subject, scoring. So 1 is correct, 2 is correct, 3 is correct. Why 1 is correct? If you keep at the same level, I can't get 30% of the water to the canals and 70% to the river stream. It is not possible. Diversion, allotment of the water through the under sluices by 70% is not possible. That is why we have to keep at somewhat lower elevation. Topmost level of the weir is at higher elevation, little bit. Topmost level of the under sluice is somewhat lower elevation. Name itself, IS code provision. The third one is given by United States Bureau of Reclamation. Also IS code has given this provision. So option is D is correct, my dear friends. Let us go to the sensitivity of irrigation module is 0.5. Percentage is also flexibility, proportionality, sensitivity and setting. These 4 definitions are very important. Here as given on sensitivity, dq by q divided by dd by d. Percentage variation in the outlet discharge, 40% variation in the canal water depth. Sensitivity is 0.5. So what is simple 1 second problem? dq by q is equal to sensitivity is 0.5, dd by d is 40%, 0.5 into 40%. Your answer for the problem will be 20% is the option. A is the option. Remember the three definitions. Kabhi kabhi only difference they are asking. Flexibility, fractional change in the discharge of the field channel by fractional change in the discharge of the parent canal. Proportionality, when the flexibility is 1, sensitivity, fractional change in the discharge of the field channel by fractional change in the depth of the parent canal. Setting, H divided by D, depth of the flow in the daughter canal by depth of the flow in the parent canal. These 4 parameters are very important. Simple answer for this is 20%. Let us go to the next question. The type of fall which you may recommend is only memory based, but with a little bit common sense. High drop, low discharges. High drop, so velocity is high. Which of these falls will suck the water with high velocity? Only siphonic action. In siphonic action, pressure will be less, velocity will be very high. So if the water is falling from a large height, the difference of maximum upstream and downstream water levels is large. The only option is go for siphon. Siphon fall. So your option is siphon. Siphon well drop is the right option. Sarda type up to 1 to 1.5 meters. Straight glaciers falls for the moderate discharges. English fall is very rarely used. So correct option is B. As per Kosla's theory, the exit gradient in the absence of a downstream sheet pile, exit gradient GE H by D 1 by pi root lambda, D is 0. Any other value by 0 will give infinity. The correct option is C. In the absence of the downstream pile, I hope you remember the water here stored is H, it is B, it is D. If we don't have this pile, what will be the value of exit gradient? Infinity is also a very, very important question. A weir on the permeable foundation with the downstream pile is as shown in the figure. What is the exit gradient as per Kosla's theory? Let us see the solution. Just now I have given the formula. GE is equal to H by D 1 upon pi root lambda. 20 and 10. So your alpha is equal to B by D. B is 20 meters, D is 10 meters, 20 by 10 that is 2. B horizontal span, D downstream pile, therefore alpha is 2. Then lambda 1 plus square root of 1 plus alpha square by 2. 1 plus root of 1 plus 4, 5 by 2. Root 5 is 2.236, so this is 3.236 by 2, around 1.618. I want GE. H by D 1 by pi root lambda, H is 5, D is 10, 1 by pi root lambda is 1.62. simplify, this is 2 times, it is nearly 1.3, 2.6, 2.6 into 3.14, 7.88. Correct option is C. 1 upon 8 is the near correct answer. You will get the value. This is the problem. Sometimes he will ask this type of questions also. Sometimes he may ask in the same type of problem. Let us see. If it is the pile given, say it is 5 meters, say it is 20 meters, say it is 10 meters, he will ask some point x, what is the phi value at x? X is the point on the bottom point of the diversion headwork of the slab, bottom floor. So, how do you get? First calculate what is h. H at x is equal to h by pi cos inverse lambda minus 2 divided by lambda. Then he will give the numerical such that you will get cos inverse function very easily, because this inverse calculator. So, he will set the values in such a way that this value is something like 1 by 2. Cos inverse 1 by 2 is pi by 3. H by pi into pi by 3, pi cancel, h by 3, h is how much? 5 by 3. So, here 1.66. What is phi? Phi is nothing but small h by capital H multiply with 100, h at x. So, he always, whenever the problems of cos inverse is involved, he will see the numericals very carefully. Otherwise, in the gate examination, such lengthy calculations will not appear. Please try to get the point. Will not appear. This is some type of questions. Let us see. For a saddle siphon, what is the maximum operating head is 6.25 meters. H operating will be 6.25 meters. Dimensions of the siphon will be 4 meters and 1.2 meters. Length is 4 meter, width is 1.5, that is 6 square meters. From this I will calculate velocity. V is equal square root of 2gh. 2 into g value 10 he has taken, 10 meters per second square. H is 6.25. Root 125, nearly 11. Area is 6. CD value 0.75. So, what is the discharge through each siphon? CD into area into velocity. CD is 0.75. Area will be 6. Velocity will be 11. It is 4.5 into 11, 44 and 5.5, 49.5, nearly 50. Each siphon spillway is able to dispose approximately 50 cubic. How much water I have to dispose? 300 cubic. So, number of siphons is equal to total discharge by discharge through each siphon. Total discharge is 300. Total discharge is 300 cubic. Amount of water disposed of by each one is 49.5, is nearly 50. You can take it as 6. Correct option for that is 6. Ogee spillway, siphon spillway, these two are very important for us. Ogee spillway, siphon spillway. Ogee spillway formula also. If it is the Ogee spillway, this is the Ogee spillway. If the head of the water is here H, this formula also you must and should remember. C into LE into HE to the power of 3 by 2. For Ogee spillway, This is very, very important. HE is nothing but static head plus kinetic head. LE, by taking into the effect of end contractions, we should take into account the effect of end contractions also and the C value. So, this is also very, very important formula. There is Ogee spillway and the previous one siphon spillway. This is the siphon spillway. Ogee spillway and siphon spillway. If the width of the river at the location of the dam is very small, narrow width, go for siphon spillway. Wide valleys, wide rivers are there, then go for Ogee spillway. For wider plains, Ogee spillway on wider rivers, siphon spillway on narrow rivers. When sand and gravel foundation strata is available at a proposed dam site of a moderate height, sand and gravel, moderate height, the dam may be of the time. Say moderate height means maximum 12 to 30 meters. The only chance is rock-filled dam or earth dam. So, masonry gravity dam we can go up to 60, 70 meters. It is not a moderate height. Double arch dam up to 120, 180 meters. Concrete gravity dam up to 200 meters. Moderate height 25, 30 meters. So, it is the earthen dam or rock-filled dam, because sand and gravel. If a rock is there, I can go for masonry gravity dam. Option, this is important keywords. In which of the following cases standing wave basin with raised floor means the slope must be as energy dissipator, slope must be mild, and this is the case. TWC must be slightly above, TWC must be slightly above JHC. TWC is slightly above, TWC is slightly above JHC, and the slope of the channel is mild. A is the correct option. All 5 cases you must remember, friends. I hope you remember. JHC, TWC are coinciding. JHC lies above TWC, JHC lies below TWC. JHC is more at low discharges and high at large discharges, and the reverse of that. All the 5 cases you must remember is one important area, but that much concentration you will not give for irrigation. Let us see for row crops, not now, row crops like potatoes and sugar beets are the most commonly adopted method of surface irrigation. Potatoes, furrow irrigation is the best, you know. So, furrow irrigation and corrugation irrigation is the one. Basin flooding for rice, check flooding for rice, free flooding is for vegetables and flowers. For basin flooding, apart from the rice, let us see. Check flooding is best for rice, free flooding for vegetables and flowers. Basin flooding for neem, mango, orange, banyan. Furrowed irrigation for potatoes, maize, jawar. For row crops, for all row crops, best method is furrow and corrugation irrigation. Right option is D. It is also asked in the recent competitive examinations. I feel this is also a guess question from the chapter. This is a simple definition. Water stored in the root zone during irrigation to the water needed in the prior to the irrigation. Storage. Water stored in the root zone during irrigation taken by the plant by water needed in the root zone prior to irrigation. Calculated value. Output value by input value, that is nothing but storage efficiency. One more question. This is the gravity dam. Reduce level plus 200 plus 290.0. Height of the wave is 3 meters. Most possible reduce level value of crest. If the height of the wave is 3 meters, reduced level of the base is 200 meters, reduced level of the normal pool level is 290 meters. What is the most possible reduced level of the crest? So, this is also one question I feel it is important. What is the reduced level of this? If I know the freeboard, then I can get the value very easily. What are the possible formulas for freeboard? Most common value 3 by 2 HW. 3 by 2 times HW. Actually, according to IS code, it is the greatest of 3 values. 0.9 meters, 3 by 2 HW, 4 by 3 HW plus VS. They are not necessary, they are not important also. Only condition 3 by 2 HW, HW is 3 meters, 3 by 2 into 3, 4.5 meters. If it is 290, this will be 294.5. So, reduced level of the crest is equal reduced level of normal pool level plus freeboard. This is 290.00 plus 4.5. Your answer for the problem is plus 294.5 meters is the right option. Plus 294.5 meters is the right option for the problem. So, it is also one important question on the gate for gate 22. Let us take one more question. Regarding limiting height. Limiting height of the gravity dam is also very important. Kindly recall the formula F divided by W into S minus C plus 1. W is nothing but gamma W. S will be generally 2.4 to 2.5. C value either 0 or 1. If a rock is there 0, any other soil is there 1. F is the permissible compressive strength of the concrete. Permissible compressive strength of the concrete. Whatever concrete you are using for the construction of the gravity dam, this formula, limiting height formula F divided by gamma water into S minus C plus 1. According to IS code, if H value is less than 88 meters, low dam. If H is more than or equal to 88 meters, it is high dam. So, such type of questions, which of the following according to IS code, which of the following is the condition for high dam or low dam? Such question may be asked. So, these are some important guess questions. I am just giving my number, and you can contact me for your doubts in irrigation. Good luck to you all. And Happy New Year to all. I wish all the best, and thank you. Any doubts, please get clarified by calling. In my free time, I will give the answer. You can send the WhatsApp also. Primarily, these 4 chapters you concentrate so that you will get the best result in GATE. Try to give the priority for most important and higher weightage subjects. 5 subjects are important for you. Number 1, environmental engineering. Number 2, geotechnical. Number 3, transportation. Number 4, strength of materials. Number 5, engineering mathematics. I wish good luck to everyone. Happy New Year once again, and kindly rely on for final touch preparation, final moment preparation, kindly rely on APL, Ace Preparation League, a supporting hand for your better success. Good luck. Thank you.